Design of single-speed FR reduction bevel gearbox. For low-speed vehicles, abstract gearboxes are designed for variable speeds and torque applications for different drives. Differential is an important component which splits the drive during turns and variable loads conditions. Differential is an expensive component which adds to the cost of the vehicle. In low-speed vehicles used for sprinkler vehicles, grass cutters etc., introducing a differential will increase the cost and complexity of the vehicle. Finding an alternate for replacement of differential which serves the same purpose at low speeds will be of great advantage in reducing the cost, complexity, construction, and maintenance. Hence this paper is aimed at making an attempt to find a similar type of alternate mechanism replacing differential with gearbox. Keywords FR, forward and reverse, reduction gearbox, bevel gears, low-speed vehicles, single-speed. 2. Introduction. Design of reduction gear train for low-speed applications is very essential to overcome the effects of sudden and variable torque. This concept of reduction gear train is considered to replace the differential with reduction gearbox with a provision of reverse drive. In low-speed vehicles used for sprinkler vehicles, grass cutters etc., the gear train is designed for an output torque of 57.6 Nm at a gear reduction ratio of 1:3.6. Taking into account the design considerations for gears and gear trains, the proposed train has been designed. Applications of this proposed gearbox are agricultural applications for weed cutting machinery, lawn moving vehicles, grass cutters, flour mills, paper mills, lathe machines, milling machines, conveyor belts. 3. Literature review. Concept of gear development, classification of gears 3, 4, 5, gear nomenclature, gear materials. Applications of gears 1-5, design and development of gear trains 2-6 are the concepts derived from standard references 1-2. 1. Recognition of need. Low-speed vehicles generally don't need differential and hydrostatic gearbox, which adds to the complexity of vehicle and increase of cost factor. An alternative to replacement of these is of great advantage which reduces the complexity and cost factor has led this work. 2. Input parameters. No. Functional design. Value. Table 3.1 BOM. 4. Design of drive and gear. Elements. 4.1 Design of drive. I. Required force to overcome inertia. F equals ma plus FR plus FS plus FD. FR equals CRR asterisk N, FR equals 15 N. FP equals ma equals 220 asterisk 2.5 equals 550 N. Total force F equals 550 plus 20 equals 570 N. We know that power equals force asterisk velocity. F equals power slash velocity equals 74475 slash 12.5. F equals 596.56 N. Engine force. Engine force. Required force. Gear ratio. Engine RPM equals 3400 RPM. Wheel RPM equals 940 RPM. Gear ratio equals engine RPM slash wheel RPM equals 3400 slash 940 equals 3.6:1 at 45 kmph. 2. Design of shaft. D equals diameter of shaft. Torque transmitted by driven puts. T equals P60 slash 2 PN2, 62.8103 Nmm. Also, TE equals P slash 16 D3. 767.28103 equals P slash 16320 N slash mm2 asterisk D3. D equals 23 mm shaft. 3. Selection of bearing. T equals 70 Nm. Tangential force. WT equals T slash RM. RM equals 70 minus 34 halves SIN 60. RM equals 45.89. 4. Axial force and radial force. RA equals WR sin dot P1 equals WT tan F sin F. RR equals WR cos P1 equals WT tan F cos F. Wt equals T/Rm. Wt equals 70 50ths nm equals 70 *103/50 nmm equals 1400 n. Ra equals 1410 60 sin 60 equals 1790 n. Rr equals 1410 30 cos 30 equals 682.23 n. Wr equals 682.23 n. Wa equals 1790 n. Life equals 20,000 hours. Life in revolutions. L equals 60 n. LH equals 60 1300 15,000. Equals 1170 *106 rev. Basic dynamic radial load. W equals x.v.wr plus x.wa. X equals WA/WRER equals WA/C0. Then X equals 0.56, Y equals 1.2. X equals 0.56, Y equals 1.2. W equals 0.561682.23 plus 1.2 *1790. Equals 0.561682.23 plus 21,348. Equals 382.0488 plus 2,148. W equals 2530.488 n. V. Basic dynamic load ratios. C equals WL/1061/K equals 2530.51170 *106/1061/3. C equals 26.664 n. C equals 26.6 knots. For C equals 26 knots, C0 equals 17.6 knots. D equals 25 mm, D equals 62, B equals 17 mm. C equals 26, C0 equals 13.4. Bearing no equals 6305 ETN9. Or, equals 6305-2Z less. Or, equals 6305 2 RSI. Straight bevel gear forces, Vorteris Technologies LLC. Figure 4.1 Dimensions. 6. Design of gear. dP equals 63 mm. dg equals 220 mm. np equals 8. ng equals 30. m equals 7.75. Pitch angles of gears. AP1 equals tan1, ng/np, equals 150. AP2 equals 300. 5 results. Following are the results obtained gear terminology values. S.No. Nomenclatures. Values. Table 5.1 Gear nomenclatures values. 6 Working. This gearbox is compatible in working with IC engine and electric drive with automatic clutch. Power from the source is transmitted to pinion as input. From pinion the power takes a right-angled turn to the gears 1 and gear 2, which will be in mesh with the pinion. These gears transmit the proportionate amount of power to the road wheels. The gear 1 and gear 2 are mounted on the shaft and can slide over the shaft manual. Meshing of pinion with gear 1 facilitated forward drive and meshing of pinion with gear 2 facilitates reverse drive. Figure 5.1 Cut section of assemblage of gear train and casing. Figure 6.1 Forward drive mesh. Figure 6.2 Reverse drive mesh. 7 Modeling tool used. SolidWorks modeling tool of release 2021 is used. Basic features are: extruded boss feature, fillet features, revolved boss feature. 8 Conclusion. The proposed reduction gearbox for low-speed vehicles has been designed satisfactorily as per the requirement to suit for the real-time working environment. Design parameters with calculated valued are identified using the standard relations which helped in manufacturing of the components of the gearbox.